So we will do this question from the topic of motion in straight line. Very important question for NEET for your practice. So let's read the question first. There is a particle moving along a straight line with an initial velocity v, u under a retardation, which is proportional to square of the velocity given by av squared. So the formula of retardation, say the retardation is a, is given by, we can't use a because we already have a here. So let's use some other word. Let's use r as the retardation. Find the time taken for the velocity to reduce to half its original value. So the focus of the question is finding the time. The retardation is given. So I will use this r is equal to minus av square to assume that this is negative sign represents retardation. Let's see what happens. Okay. Now let's start solving this. As you can see, the retardation is proportional to v square. Okay. So I can write retardation as dv by dt is equal to minus av square. Okay, and then I can write dv by v square is equal to minus a dt, integrating both the sides. Okay, let's integrate. So this will give me minus dv by v is equal to minus at plus c. Now the initial velocity at t is equal to 0, right? The velocity is how much? U. It is given in the question. You can see the first line of the question. It says the velocity is u. Okay, so I'm going to use this and write it. So this will be minus dv by u is equal to, sorry, we will not have any dv here. I will just rub this off. I think I have not. Okay, so this is going to be minus 1 by v is equal to minus at, and then we will use the initial condition at t is equal to 0. So c is equal to minus 1 by u because I put t is equal to 0 in this equation. So c, the integration constant, has come out to be minus 1 by u. Okay, let's move forward in this question. Still, what we have been able to find is that minus 1 by v is equal to minus at minus 1 by u. So this equation we have found out. Okay, but our focus is to find the t. Okay, let's go back to the question and say, it says the velocity reduces to half its initial velocity in how much time? Okay, now we know that if I rewrite this whole equation, because I need the velocity. So my velocity minus 1 by v. Okay, so minus 1 by v is equal to minus 1 by u minus at. So I will remove the minus sign from all of them. So this will become 1 by v is equal to 1 by u plus 1 by, plus a t. So this is my equation. Let's write the whole equation. So it's 1 by v is equal to 1 by u plus a t. We have to find the time required to make the velocity as half, right? So at what time the v will become u by 2. So let's put the value here and see. So 1 upon u by 2 is equal to 1 by u plus at. So this is 2 by u is equal to 1 by u plus at. So 1 by u, 2 by u minus 1 by u is equal to at. So 1 by u is equal to at. So t is equal to 1 by au is the correct answer.